Hi there, in this video clip today I want to talk about acids, alkalis, the pH scale, neutralisation and the strength of acids. Let's look at the formula of some typical acids. First one, HCl, hydrochloric acid, HNO3, nitric acid, H2SO4, sulfuric, H2CO3, carbonic acid, ethanoic acid, CH3COOH. Why are these classified as acids? It's because if you add them into water, they produce hydrogen ions. So if I add them to water, they all produce hydrogen ions, H plus Cl minus, nitric acid, H plus the nitrate anion, sulfuric acid plus sulfate anions. It's a new acid, I don't think I've mentioned it before. Carbonic acid gives you 2H plus the carbonate anion, and this is ethanoic acid. It produced the ethanoate ion plus hydrogen ion. I'm going to change that now, that sign, into that sign, which means it's reversible, but I'll speak about that in a moment. I'm going to draw a line across there. These acids on the top are called strong acids because the strong acids, because they completely ionize or dissociate into hydrogen ions when they're added to water. And the opposite of strong is weak acids. These are acids that partially, don't completely ionize into hydrogen ions when added to water. How do we know whether something is an acid or an alkali? We use indicators. Indicators are simply dyes which are added to water to produce a solution, and the classic is litmus paper. You dip your acid in litmus paper, and if it turns red, it's an acid, and if it turns blue, it's an alkali. That's one way, and the other way is you can get a special paper that's called pH paper, which measures the pH of a solution. The pH of a solution gives you a measure of the strength of an acid or an alkali. It starts at 0 and ends at 14. 0 to 14. 7 is neutral. So from 0 to 7 you've got an acid, and from 7 to 14 you've got an alkali. This is strong acid here. Strong would have a pH of 0 or 1ish, and this would be water is neutral. Water is neutral. It's neither acidic or an alkali. And this 14 would be a strong alkali. I'll get back to that soon. I mentioned strong and weak, and on the pH scale, acids go from 0 to 6.99999, and alkalis go from 7.00000 to 14. So the pH scale measures the strength of an acid or an alkali. I remember science days, or when I spoke about something a bit earlier on, I spoke about the colours of the spectrum, where, do you remember this? Richard, the mnemonic, Richard of York gave battle in vain. Red, orange, yellow, green, blue, indigo and violet. Using pH paper, greenish would be neutral, red would be a pH maybe about 1, violet pH about 14, and this is pH paper. pH paper can be used to measure the strength of an acid or an alkali. So if it turns red, I'll be here with pH paper, it's strong. Violet or bluish, it's going to be an alkali. Now, what is an alkali? I've said acids dissociate to produce hydrogen ions, and an alkali is something that dissociates in water to produce hydroxyl ions. Let's look at a couple of these. Sodium hydroxide, potassium hydroxide. Wrong. These are strong alkalis. They completely, 100% dissociate into sodium ions and hydroxide ions. Potassium hydroxide completely dissociates into potassium ions and hydroxide ions. And it's the presence of those hydroxide ions that makes something an alkali. Sometimes they use the word base, but I prefer an alkali. And guess what happens when you add an acid to an alkali? The acid neutralizes the alkali, or vice versa, because the hydrogen ions react with the hydroxide ions to produce good old water, H2O. So today I've explained what is an acid, what is an alkali, the strength of acids, the strength of an alkali, the pH scale 0 to 14, that determines the strength. I mentioned what is a strong acid and what is a weak acid, and the same applies. What is a strong alkali, what is a weak alkali? Strong alkali completely dissociates in water to produce hydroxide ions.